my dear children, welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the problems in the exercise 7.6, page number 327 in the textbook. Okay, my dear children, in the previous class, we have discussed the concepts of exercise 7.6, integration by parts. By using that concept, we solve the problems. We integrate the functions given in this exercise 7.6. Okay, my children. And we have completed 4 questions. We have discussed 4 questions so far in this exercise 7.6. Here I am not explaining question number 5 and question number 6. Please try yourself the 2 questions, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 7. Are you ready to listen the class? Right. Integrate x sine inverse x. Understood this question, my dear children? We have to find the integral of x sine inverse x dx. Okay, my dear children? Right. Come to the solution. There are 2 methods to find the integral of x sine inverse x dx. To evaluate integral x sine inverse x dx, there are 2 methods. First method, using integration by parts directly. By using the previous knowledge, the concepts of integration by parts. How do you find integral of product of 2 functions? First we had to arrange the 2 functions. We had to arrange the 2 functions in the product in this order. Eilate. Do you remember this word, my dear children? Eilate. So first we had to identify which kind of functions these 2 functions are. See here, first function, this is x. This is a algebraic function and this is a trigonometric function. Out of these 2 functions, first function is given as algebraic function and second function is given as inverse trigonometric functions. Inverse trigonometric function. Inverse trigonometric. So inverse trigonometric function. So these 2 functions are convenient order, because first function should be inverse trigonometric function and next one should be algebraic function. So we have to rearrange these 2 functions, but they are given in the reverse order. First is given as algebraic and second function is inverse trigonometric. So we have to rearrange these 2 functions. Okay, my children? Right. Integral sine inverse x into x dx. Okay, my children, we rearranged these 2 functions. First we have taken sine inverse x as first function and second function is x. Okay, my children. Now we apply integration by parts. Okay, my children. What is the formula? First function, that is in sine inverse x into integral of second function, integral x dx, minus integral of d by dx of first function, that is sine inverse x, into integral second function dx, whole dx. Okay, my children, by using integration by parts, we wrote this step. Okay, my children, understood this step? Right. That is equal to sine inverse x into integral x dx. It is in the form of integral x power n dx, where n is equal to 1. Okay, my children, we have to identify which formula is apt, which formula is suitable for evaluating this integral. So integral x power n. So x power 1 plus 1 by 1 plus 1. We used that formula, integral formula. Okay, my children, understood this part? Right. Minus integral of d by dx of sine inverse x. What is the formula? Do you remember that? 1 by root of 1 minus x square. Okay, my children, into same integral. So x power 1 plus 1 by 1 plus 1 whole dx. Okay, my children, what are the formulas we used in this step? Integral x power n dx is equal to x power n plus 1 by n plus 1. To evaluate this integral, we used this integral formula and derivative formula d by dx of sin inverse x is equal to 1 by root of 1 minus x square. This derivative formula, this integral formula and this derivative formula are used to write this step. Okay, my children, understood this step? Right. This is equal to sin inverse x, then what will you get here? X to the power of 1 plus 1, 2 by 2. Okay, my children, understood this part? Right. Minus integral 1 by root of 1 minus x square into what we get here? Here also we get x square by 2 whole dx. Okay, my children, understood this one? Right. Now let us rearrange these terms. X square by 2 into sin inverse x. Okay, my children, here 1 by 2 is a numerical coefficient. We can write it before the integral sign. So minus 1 by 2 integral x square by root of 1 minus x square dx. Okay, my children, understood this step? Right. Let us assume that this integral is I1. Okay, my children. Therefore, I is equal to x square by 2 sin inverse x minus 1 by 2 I1, where I1 is equal to integral x square by root of 1 minus x square dx. Let us assume that this integral is capital letter I1. Let us find this integral separately. Okay, my children? Right. Let us consider this equation is 1. I is equal to x square by 2 sin inverse x is equal to 1 by 2 I1. Let us assume that this equation is 1. Okay, my children? Right. To evaluate this integral, now I1 is equal to integral x square by root of 1 minus x square dx. To evaluate this integral, we use our previous knowledge. In the exercise 7.2, we used substitution, integration by substitution. We use that knowledge here to evaluate this integral. Okay, my children, put x is equal to sin theta. Put x is equal to sin theta. Put x is equal to sin theta. Now differentiating with respect to theta. Differentiating with respect to theta, because x is defined in the variable theta. So we are differentiating this equation with respect to theta. Okay, my children. This implies what is the derivative of x? 1 into dx by d theta is equal to what is the derivative of sin theta? Cos theta. Understood this step, my children? Please recall that previous knowledge. Bring that previous knowledge into your mind, my children. Okay, these steps, we followed these steps in the integration by substitution method. Isn't it or not, my children? Yes or no? Yes. So from this equation we find dx. Dx is equal to cos theta d theta. Okay, my children, we found dx value. Therefore, I is equal to Therefore, I1 is equal to integral x square, that means sine square theta, by root of 1 minus sine square theta into dx. What is the value of dx? Cos theta d theta. Understood this step, my children? We substituted this value and dx value in this I1. Then we got this step. Okay, my children? Right. This is equal to integral sine theta by 1 minus sine square theta. What is the value of 1 minus sine square theta? Cos square theta. Root cos square theta. What you get? Cos theta. Directly I am writing cos theta into cos theta d theta. Okay, my children, understood this step? What is this cos theta? Understood this cos theta, my children, in the denominator. Right. Now, strike out cos theta, cos theta. Then what will you get here? Dx integral sine square theta d theta. Integral sine square theta d theta. Okay, my children, after striking out these cos theta, we got integral sine square theta d theta. Again, we have to use our previous knowledge using trigonometric identities in the exercise 7.3. We used that previous knowledge. So 1 minus cos square sine square theta can be written as integral 1 minus cos 2 theta by 2 d theta, because 1 minus cos 2 theta is equal to 2 sine square theta. This formula is derived from multiple angles. Okay, my children? Right. So, sine square theta can be written as 1 minus cos 2 theta by 2. Now, let us split into two integrals. That is equal to 1 by 2 integral 1 minus cos 2 theta d theta. Here 1 by 2 is a numerical coefficient. We are writing it outside. Okay, my children. Now, we are writing the remaining function. Okay, my children. That is equal to 1 by 2 into integral d theta minus integral cos 2 theta d theta. Here we are finding the integral of these two terms separately. Understood this step, my children? Right. That is equal to 1 by 2 into integral theta means integral dx. Integral 1 dx means dx. So integral 1 d theta means theta. Understood this theta, my children? Right. Minus integral, it is in the form of integral cos of ax plus b, linear expression. So sine 2 theta by 2. Sine 2 theta by 2. Because integral dx is equal to x. For the first term, we used this integral formula, and integral sine of cos of integral cos of ax plus b dx is equal to sine of ax plus b whole divided by a. By using these two integral formulae, we wrote these two terms. Okay, my children, understood? Right. Again, here we have to use sine 2 theta formula. Okay, my children. So 1 by 2 into theta minus, what is the formula of sine 2 theta? 2 sine theta cos theta by 2. Okay, my children, because sine 2 theta is equal to 2 sine theta cos theta. Multiple angle formula. Okay, my children, do you remember this formula? We used this multiple angle formula in the numerator. Okay, my children, Understood? Right. Now here 2 gets cancelled. So 1 by 2 into theta minus sin theta into cos theta. Okay, my children. But we have, this is a I1 value, but the given function is in terms of x, but here we got to answer in terms of theta, so we had to reduce, we had to transform into x in terms of x, we had to transform into x terms. Okay, my children, that is equal to 1 by 2 into, previously we have considered x is equal to sin theta, then theta is equal to, what will you get, sin inverse x, minus, we have assumed sin theta is equal to x, into cos theta can be written as root of 1 minus sin square theta, isn't it or not, my children? So root of 1 minus x square, because x is equal to sin theta, x is equal to sin theta, y implies theta is equal to sin inverse x, and cos theta is equal to, and cos theta is equal to 1 minus sin square theta. So by using these results, we wrote this function in terms of x. Theta is equal to sin inverse x. Understood? This is sin inverse x, my children. Minus sin theta means x, into cos theta means 1 minus sin square theta. Okay, my children. Cos theta means root of 1 minus cos square theta. Okay, my children. This is I1 value. Therefore, I1 is equal to 1 by 2 sin inverse x minus x root of 1 minus x square by 2. Let us consider this is I2. From equations 1 and 2, from the equations 1 and 2, we get I is equal to x square by 2 sin inverse x minus 1 by 2 into I1. What is I1 value? 1 by 2 sin inverse x minus x root of 1 minus x square by 2. In the equation 1, we substituted this result I1. Okay, my children? Right. Understood this step? Right. X square by 2 sin inverse x. Let us use the distributive property. Minus 1 by 4 sin inverse x minus of minus plus x root of 1 minus x square by 4 plus c, because integration part is also over, simplification of the terms is also over. This is the last step. So at the last step we should add constant of integration. Okay, my children? Understood? Right. Previously I told you there are two methods to evaluate integral x sin inverse x dx. In the previous method we used directly integration by parts method. Okay, my children? But in this method too, first we use inverse trigonometric functions concept, and after that integration by parts. Okay, my children? We don't directly use integration by parts method here. Okay, my children? Understood? Right. So first we assume that sin inverse x is equal to theta. Okay, my children? You have already learnt, you have already studied inverse trigonometric functions chapter. So if sin inverse x is equal to theta, then what will get? X is equal to sin theta. Isn't it or not, my children? Sin inverse x is equal to theta, then x is equal to sin theta. Then if you differentiating with respect to theta, then what will you get? X, derivative of x is equal to differentiating with respect to theta. This implies x, derivative of x is 1 into dx by d theta is equal to derivative of theta, sin theta derivative is cos theta. Okay, my children, understood this one. So dx is equal to cos theta d theta. Okay, my children, understood this one? Right. Therefore, I is equal to integral x is there. What is meant by x here? Sin theta into sin inverse x. Sin inverse x means theta into dx. What is the value of dx? Cos theta d theta. Okay, my children, understood this step? Right. Now, integral, that is multiply and divide by 2. Okay, my children, 1 by 2, 2 sin theta cos theta into theta d theta. Understood this step, my children? I multiplied and divided by 2 to get this part. 2 sin theta cos theta means sin 2 theta. Isn't it, or not, my children? Yes or no? Yes. So integral sin 2 theta into theta d theta. Okay, my children? So inverse trigonometric functions is converted into trigonometric functions. Now we use the integration by parts. After this step, we use integration by parts. Here this is a trigonometric function and this is a algebraic function, because here variable is theta. So theta is said to be algebraic. So you have to remember this word, eilate. Here first trigonometric function is there and next algebraic function is there. But these two functions should be in this order. First algebraic function should be, and after that second function should be trigonometric. But here functions are in a reverse order. So let us arrange them in the particular order. So integral 1 by 2 theta into sin 2 theta d theta. Okay, my children, understood this step? Just we rearranged according to our convenient. We rearranged these two functions according to our convenient. Now this is algebraic and next trigonometric. Okay, the functions are in convenient order to apply integration by parts. Okay, my children. So this is the first function and sin 2 theta is a second function. Okay, my children. So 1 by 2 into first function into integral of second function minus integral d by dx of, means d by d theta of theta into integral second function whole d theta. By using the concept of integration by parts, we wrote this step. Okay, my children, understood this one? Right. Okay, my children, understood this step? Right. That is equal to, see here, my children, 1 by 2 into theta into integral sin 2 theta d theta. It is in the form of integral sin of ax plus b, linear expression. So minus cos of cos 2 theta by 2. This is the integral of this function. Okay, my children, minus cos 2 theta by 2 minus integral of integral d by d theta of theta, what will get? 1. So 1 into here, what will get? Integral sin 2 theta minus cos 2 theta minus cos 2 theta by 2. Okay, my children, understood this part? I wrote it directly. 1 into any function, we get the same function. So minus cos 2 theta by 2. Understood this step, my children? Right. This is equal to 1 by 2 into minus theta cos 2 theta by 2 minus of minus, what will you get? Plus 1 by 2 integral cos 2 theta d theta. Understood this step, my children? I wrote 1 by 2 as it is. I simplified this term, so minus theta into cos 2 theta by 2 minus of minus, we get plus integral cos 2 theta d theta. Understood, my dear children? Right. That is equal to 1 by 2 integral minus theta cos 2 theta by 2 plus 1 by 2 integral cos 2 theta d theta. Again it is in the form of integral cos of ax plus b. Okay, my dear children. So sin of ax plus b means sin 2 theta by 2. So this is the integral of integral cos 2 theta d theta, sin 2 theta by 2, because integral cos of ax plus b dx is equal to sin of ax plus b by a. Okay, my children, by using this integral formula, we wrote this step, we wrote this part. Okay, my children, so integral part is over. Now let us simplify. Okay, my children, right. So minus theta cos 2 theta by 4, I am multiplying by 1 by 2 plus 1 by 8, 2 2s are 4, 4 2s are 8, sin 2 theta. Okay, my children, we got answer in terms of theta, but actually the function is given in terms of x. So we have to convert these functions in terms of x. Okay, my children, right. So minus theta cos 2 theta can be written as 1 minus 2 sin square theta whole divided by 4 plus 1 by 8 2 sin theta cos theta. Understood this step, my children? Cos 2 theta is written as 1 minus 2 sin square theta because cos 2 theta is equal to 1 minus 2 sin square theta and sin 2 theta is equal to 2 sin theta cos theta. By using these two formulae, these are said to be multiple angle formulae. By using these two formulae, we wrote this step. Okay, my children, understood this step? Right. This is equal to minus theta into 1 minus 2 sin square theta whole divided by 4 to 1 times to 4 times, that is equal to 1 by 4 sin theta into 1 minus sin square theta. Cos theta can be written as, I wrote cos theta can be written as square root of 1 minus sin square theta. Okay, my children? Right. Now we substitute theta is equal to sin x, sin theta is equal to x. Okay, my children? Right. So minus sin x at the beginning what we have considered sin inverse x is equal to theta. So sin inverse x, theta is equal to sin inverse x into 1 minus 2 sin square theta means 2x square. Okay, my children, sin theta is equal to x. So 2 into x square plus 1 by 4 sin theta means x into root of 1 minus x square. Okay, my children, understood this one? This whole divided by 4. Whole divided by 4. Now let us simplify these terms. Let us simplify these terms. That is equal to minus sin inverse x by 4 minus sin inverse x by 4 plus 2x square sin inverse x by 4 plus 1 by 4 x root of 1 minus x square. Just I used here distributive property. So minus sin inverse x by 4 minus plus 2x square sin inverse x by 4. I wrote this last term as it is. Okay, my children, understood this step? Right. Now let us simplify these terms. Integration part is over. Now let us simplify the terms. Here 2 1 times, 2 2 times. Okay, my children. This implies I is equal to minus sin inverse x by 4 plus x square by 2 x square sin inverse x square sin inverse x by 2 plus 1 by 4, or we can write x root of 1 minus x square whole divided by 4 plus c, because simplification part is also over. We can write at the last step, we can add constant of integration. Okay, my children, understood? Right. If you compare the answers in the method 1 and method 2, if you compare the answers in the method 1 and method 2, you got the same answer. Okay, my dear children? Right. So if you can follow any one of these two methods which is convenient to you. In the examination, you can follow any one of these two methods. No need to write two methods. Only one method is enough in the examination. Okay, my dear children? Understood? Right. Please do the remaining questions in this exercise, my dear children. Question number 8, question number 9, question number 10, question number 11. From question number 9 to question number 15. Use the integration by parts method, my dear children. If you get a inverse trigonometric function, then I think the second method is convenient to integrate that function. I feel the second method, as we have followed second method for the question number 7, I think and I feel that the second method is easier to you. Okay, my dear children? Right. Now, next type of functions. Integrals based on formula integral e power x into f of x plus f dash of x dx is equal to e power x into f of x. Okay, my dear children? By using this formula, we have to evaluate the integrals. Okay, my dear children? See the question number 16. Integrate e power x into sin x plus cos x. Okay, my dear children? Right. Let us assume that capital letter I is equal to integral e power x into sin x plus cos x dx. We assume the given integral is capital letter I. Okay, my dear children, understood this step. And put that sin x is equal to f of x. Let f of x is equal to sin x. Then What is f dash of x? What is the derivative of sin x? Cos x. Isn't it or not, my children? So the given function is in the form of integral e power x into f of x plus f dash of x dx. Therefore, I is equal to integral e power x into f of x plus f dash of x dx. Then what is the formula? E power x into f of x. E power x into f of x. Okay, my children, understood this step? Right. E power x into what is assumed as f of x here? Sin x. E power x into sin x plus c. Understood this step, my children? This is another type of functions. To integrate this type of functions, we have to follow this formula. Okay, my children, understood this step? Understood this question? Right. Now come to the question number 17. Integrate x e power x by 1 plus x whole square. Okay, my children, understood this question? We have to evaluate integral of x e power x by 1 plus x whole square dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral x into e power x by 1 plus x whole square dx. Okay, my children, you know this first step. Understood this step, my children? Right. Now let us change this function according to our convenient. Okay, my children? Right. Integral e power x into, here x is there in the numerator, we can write it 1 plus x minus 1. Isn't it or not, my children? By 1 plus x whole square. Can we write it or not, my children? Here 1 minus 1 gets cancelled. Again, we get x only. So for our convenient, I wrote x as 1 plus x minus 1. Okay, my children? Understood? Right. That is equal to integral e power x into, here I am assuming that this is first term, this is second term. So 1 plus x by 1 plus x whole square minus 1 by 1 plus x whole square dx. Just I am splitting into fractions by assuming that 1 plus x as first term, minus 1 is second term. So 1 plus x by 1 plus x whole square minus 1 by 1 plus x whole square. Okay, my children, understood this step? Right. Here 1 plus x gets cancelled. That is equal to integral e power x into 1 by 1 plus x minus 1 by 1 plus x whole square dx. Okay, my children, understood this step? Right. Now let us assume that 1 by 1 plus x is equal to f of x. Let f of x is equal to 1 by 1 plus x. Then f dash of x is equal to, let us find the derivative of this function, 1 by 1 plus x. It can be written as 1 by d by dx of 1 by 1 plus x. How can you write? D by dx of 1 plus x whole power minus 1. Isn't it or not, my children? Can we write it like this or not? Yes or no? Yes. So it is in the form of d by dx of x power n formula. So 1 plus x whole power minus 1 minus 1. N into x power n minus 1. Isn't it or not, my children? So minus of 1 plus x whole power minus 2. That is equal to 1 by 1 plus x whole square. Isn't it or not, my children? That is the derivative of 1 by 1 plus x. So f dash of x, the derivative of this function is minus 1 by 1 plus x whole square. So if you assume here this is f of x plus this is a derivative of f dash of x. So it is in the form of integral e power x into f of x plus f dash of x dx. Isn't it or not, my children? Yes or no? We assumed here f of x is equal to 1 plus x, then f dash of x is minus 1 by 1 plus x whole square. We found here in rough work. Okay, my children. So what is the formula? E power x into f of x. What is assumed as f of x here? 1 by 1 plus x. So 1 by 1 plus x plus c. This is a final step. So at final step we are adding constant of integration. Okay, my children, understood this question? Right. Please try the question number 18, 19 and 20. Okay, my dear children, by using the same formula, convert the given function into this form, integral e power x into f of x plus f dash of x dx. Convert the given function into this form, then we can easily, you can easily find the integral of the function. Okay, my dear children, will you try the question number 18, 19 and 20 also, my dear children? Please try the 3 questions and remaining questions also, my dear children, which were not explained in this exercise. Please try the questions yourself. If you have any doubts at any step, ask your doubts and get your doubts clarified. Okay, my dear children, in the next class I will explain next concept, next exercise concept. Okay, my dear children, right.